Hello friends, welcome back to our channel. So in today's session we'll see one more concept in operating systems, that is variable partitioning in memory management. So in our previous session we have seen one type of technique we have seen under the contiguous memory allocation, that is a fixed partitioning. So where the number of partitions will be fixed during the configuration itself. So that's why we are calling it as a static partitioning. And also we have seen what are the advantages and disadvantages of the static partitioning or a fixed partitioning, right? So now we'll go with another technique in contiguous memory allocation, that is a variable partitioning, which overcomes the drawbacks which we have addressed in fixed partitioning. So without delay, let us start the session. So variable partitioning. So the first point, so these partitions will be used in a multiprogramming. So whenever we are dealing with the multiprogramming, then these memory allocation techniques will be used. Because so coming to the uniprogramming, so we have seen in different types of memory management techniques, right? In that video we have seen the two categories, that is a uniprogramming and a multiprogramming. So where uniprogramming, only one process can be loaded into the main memory at a time, so there will be no problem with that. Okay, after one process the another process will be coming. But coming to the multiprogramming, multiple processes will be waiting for the CPU. So multiple processes can be loaded into our main memory, so then we'll be having the problem. So where and how much memory should be allocated, so in that we are using this variable partitioning. So this will be suitable for multiprogramming, suitable for multiprogramming. And the next immediate point is, so depends upon the partition size, the partition will be created during runtime. So these partitions, so we can call them as a partitions or fragments or holes. Okay, and these partitions can be done during runtime. So this is called as a dynamic partitioning. So if we want to load a process into this main memory, so based upon the size of the process, okay, based upon the size of the process, and the partition will be created, right? So based on process size, the partition will be created during runtime. Okay, so that's why we are calling it as a dynamic partitioning. So also known as dynamic partitioning. Right, also known as a dynamic partition. So there will be no overlapping. Here also there will be no overlapping. No overlapping of partitions. And here also only one process can be loaded into one partition. So there will be no overlappings. Okay, one partition. So example, let us take an example. This is the main memory. So the first part will be always the operating system. Let us take partition 1, partition 2, partition 3, and this is of 10 MB size, process P1. This is of 5 MB size, partition P2. This is of some 7 MB size. Okay, so during runtime, so all these will be the free memory. Okay, so this will be the free space or a free memory, unallocated memory. We can call it as an unallocated memory. Now, whenever P1 wants to store into the main memory, what is the size of P1? 10 MB. So, from this free space, 10 MB of space will be allocated, I mean created, and P1 will be loaded into here, right? And coming to, and all the remaining is a free space. Okay, all the remaining is a free space. So whenever P2 wants to load into the main memory, and again this, from this free space, only 5 MB. So P2, only 5 MB size partition will be created and P2 will be loaded into that partition. And now coming to the P3, 7. So one more partition with 7 MB will be created and P3 will be loaded, and all the remaining will be the free memory or unallocated memory. So we can accommodate some more processes into this free memory until the main memory is full. Okay, until the main memory is full. Okay, so during the runtime, depends upon the size of the process, these partitions will be created. So that's why we are calling it as a dynamic partitioning. Now, what are the advantages of these dynamic partitioning? So you can observe, so advantages. So the one first advantage is, so there is no wastage of memory. Okay, so in fixed partitioning, so all the partitions will be with a fixed, either fixed number of partitions or a fixed size partitions. So there we have noticed that there will be a internal fragmentation. So obviously, if the partition size is less than, it's a greater than the process size, some memory will be wasted because all the partitions are already created during the configuration itself, right? So obviously there will be some wastage of memory, that we are calling it as a internal fragmentation. But here depends upon the process size we are creating the partitions, so there will be no wastage of memory. So the first advantage, no internal fragmentation, which is a drawback in variable size, fixed size. No internal fragmentation, there will be no internal fragmentation. And another one, so number of processes can be, I mean it is not limited to the process size. Okay, no limitation of process size, no limit on processes or process size. So if P4 is of 50 MB and if there is a free memory, automatically 50 MB can be loaded into this particular partition. So there is no fixed on, there is no limit on the process size or a processes. Number of processes can be accommodated in the main memory until there is a free space in the main memory. So these two are the advantages, no internal fragmentation. Coming to the disadvantages, I will write here. Disadvantages. See. So during runtime, the partitions are being created. So complex to implement this kind of architecture, somewhat complex when compared to the fixed partition. And the second one, there will be external fragmentation. So this is a common external fragmentation. I'll explain you. There will be a possibility of external fragmentation. For example, let us take here a few more processes. See, let it be P4. 50 MB and P5 20 MB, for example. Okay, so 20 MB. Now, so all the memory has been filled. Okay, complete memory has been divided into partitions. Now, there is a one more process we want to load into the main memory. Okay, so which is of some 10 MB. 10 MB. But here there is no space to accommodate this process. So meanwhile, P2 completed its execution and P3 completes its execution. Okay, for example, okay, so let us take P2 and P3. See, P1 completes its execution 15 MB. Okay, P3 completes its execution. Now you can observe in this example, so one process we want to accommodate which is of how much? 15 MB space. Okay, 15 MB size. And here we are having, so total free memory in this main memory is 10 plus 7 because P1 completes its execution as well as P3 completes its execution. So total free memory is 17 MB free memory. So we know that if there is a free memory, we can easily accommodate a process into that free memory. But here, these two are not in a contiguous memory locations. So this partition is already allocated, I mean created. So these two, the complete 17 MB is associated with two different partitions. So we can't combine these two partitions. Okay. So here we are having the external fragmentation. So that is a one drawback in this particular variable partitioning. So one thing can be overcome this external fragmentation by using the process called compaction. We can avoid the external fragmentation by using the word compaction, the process compaction. Compaction means, so all the processes will be loaded top and all the free memory will be allocated down, and all the free memories will be merged and forms a single partition. For example, the compaction of this one will be, so you will be seeing P2. So P2 will be allocated here with a 5 and P4 is allocated here, P5 is allocated here with a 50 MB and yes, P5, oh, sorry, this is P4, P5 is allocated here with a 20, okay, and all the remaining free space will be joined here, right? So what is the free space? 17 MB is the free space. So this is a free space. So obviously what we are doing, so we can accommodate this P6 into this particular free space. Okay, this process we call it as a compaction. Okay, making the partitions, combinedly making these partitions in a free space to avail or to accommodate one more process. Okay, so whenever a process wants to be loaded into the main memory, so first it will check whether the size fits with the already available free partitions or not. So already partitions are here. Now for example, after some time P7 should be accommodated with some 10 MB, okay, and P4 completes its execution. See, P7 can be accommodated here. So that's why first it will check with the available partitions, whether available partition can accommodate the process or not. If not, then it will go with the compaction process. So is it possibility to join two or more free space partitions to make a single partition. So if there is a availability, then automatically P7 will be loaded into that particular partition. If it is not availability, then it will go with the compaction. It will check for the compaction. Okay, all these happens only when the main memory is completely allocated with the processes. If there is a free space in the main memory, there is no question of compaction also. So directly one more partition will be created and process will be accommodated in that particular memory. So when the complete memory is filled with all the processes, then if one more process wants to be get loaded into the main memory, in such case it will check for the free partitioning whether this process can be accommodated or not. If not, then it will go with the compaction. Right? Yes. So this is called a variable partitioning. So advantages: no internal fragmentation and no limit on the process size or a process. And one disadvantage is a complex, because during runtime it have to create the partitions, so somewhat complex when compared to the fixed partitioning. And another one is a external fragmentation. Right? So let's stop here, and hope you enjoyed the session. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.